quadratic equations. We were working with quadratic equations. I hope one, all of you are able to hear me, and second, you are able to see the board. Okay. Font is a little small. Maybe I will increase my font size. So in the last class, in the first class, we worked on completion of squares. Then in the last class, I told you the formula. We derived the formula minus b plus minus root over of b squared minus 4ac by 2 times a. Then we also explored the different possibilities. That is, if b squared minus 4ac is less than 0, that is, if the discriminant is less than 0, we get imaginary roots. We say that the roots don't exist. Then if b squared minus 4ac is equal to 0, you will get a real rational roots which are equal. Yeah, you will get real rational roots which are equal, because this discriminant part will become 0, and the root will be minus b by 2a and plus b by 2a. So that is what is going to be the root. If b squared minus 4ac is, I'm sorry, it will be minus b by 2a, no minus and plus. So it will be minus b by 2a. Then we saw if b squared minus 4ac is a perfect square. If b squared minus 4ac is a perfect square, then you get a real unequal rational roots. Real unequal rational roots. Okay. Then if b squared minus 4ac is not a square, then we get a real and irrational roots. Okay, real and irrational roots. So these are the things that we learned in the last class. Yeah. So what we are going to do is we are now going to move ahead, and then we are going to move ahead of this. Okay. So here is a question. I think in the last class I was also explaining to you sum of roots and product of roots. So I am saying, suppose you have x square plus bx plus c as a quadratic equal to 0, let us say, and you can say that this is equal to x minus alpha into x minus beta, where alpha and beta are the roots. Then suppose I expand this, I'll get x square minus alpha x minus beta x plus alpha beta. So I can say this is equal to x square minus alpha plus beta x plus alpha beta. Yeah. So what can we conclude from here? We can conclude that b is equal to alpha plus beta, that is minus, no, so minus b is equal to alpha plus beta, and I can say c is equal to alpha into beta. That is, the coefficient of x is negative of sum of roots, and the constant is equal to the product of roots. Sometimes we may have the equation like this: ax square plus bx plus c. Okay, so if we have it this way, then I can say this is equal to a x square plus b by a x plus c by a, and we can say this is equal to a into x minus alpha into x minus beta, where alpha and beta are the roots of the equation. Then what will I get? I'll get a x square minus alpha plus beta x plus alpha beta. So now on comparison, I see that the sum of roots is equal to minus b by a, and the product of roots is equal to c by a. Okay, so this is the general form of a quadratic equation. So this is equal to 0 is an equation. So this is what it is. So I think this is where we stopped in the last class. So if you can make some notes, we will carry on from here. I'll just come back. Yeah, so I hope you are all able to hear perfect, and I hope you are able to see what I am writing, and I hope you are able to understand what I am doing. Okay, so if this is understood, okay, so if this is understood, then let us move on from here. Let us move on from here. First slide, second slide, third slide, fourth slide, fifth. I've given you 2 questions. Yeah, can you quickly work this out? Okay. So the first one, the way I go ahead with it is I simply write down 5x square. I think of two numbers whose product is 100, whose sum is going to be minus 15. So I'll say minus 20x plus 5x minus 20 is equal to 0. Take 5x common, so I'll get x minus 4, plus again I'll take 5 common, I'll get x minus 4. So I'll get 5x plus 5 and x minus 4. So x is equal to 4 and x is equal to minus 1. Yeah. Then second question is, will the following cut the x-axis? It will cut the x-axis if you can, if this is equal to 0, will give you real roots. So you want to check whether it has real roots or not. For real roots, b squared minus 4ac should be greater than 0. So let me check. B square is 25 minus 4 into 10. This is equal to minus 15, which is less than 0. So discriminant is less than 0. So roots are imaginary. Yeah, discriminant is less than 0. So roots are imaginary. Okay. So this is how you do it. Yeah, so whenever they ask you whether a particular graph is going to touch the x-axis or not, if it has real roots, it will touch the x-axis. So based on that, you can conclude. Okay, so now let's move on. So here is the next question. Let ax square plus bx plus c equal to 0. Okay, and let alpha and beta be the roots of the equation. Then find alpha square plus beta square. Yeah, so let ax square plus bx plus c equal to 0, and let alpha and beta be the roots of the equation. Then find alpha square plus beta squared, then 1 by alpha plus 1 by beta, 1 by alpha squared plus 1 by beta squared. These 5 questions are there. Okay, so please work on that. Yes, complex numbers are same as imaginary. Will you explain the first sum once more? The first sum, I am trying to find out the roots of the equation. Okay, so for the roots of the equation, I'll write it again and then explain. So the question is 5x square minus 15x. So 5x square minus 15x minus 20 is equal to 0. Okay, so there are two ways I can do it. In the first step, I can take 5 common. So if I take 5 common, it becomes x square minus 3x minus 4 is equal to 0. Now I think of breaking it up into two factors. So I think of two numbers whose product will give me minus 4 and whose sum is equal to minus 3. So I can split the middle term as x square minus 4x plus x minus 4 is equal to 0. So now I can say 5, and then now I can factorize this x minus 4 into x plus 1. This is equal to 0. So either x should be equal to 4 or x should be equal to minus 1. Okay, so this is one way you can do it. What I did is 5x square minus 15x minus 20. I did not take 5 common. So I said, let me think of two numbers whose product is equal to minus 20 into 5 and whose sum is equal to minus 15. So very clearly these numbers itself will give me minus 15. So I split the middle term as 5x square minus 20x plus 5x minus 20. Then I took common and then I worked it. So I got 5x plus 5 into x minus 4. So 5x plus 5 is equal to 0 or x minus 4 is equal to 0. So this will give me x is equal to minus 1. This will give me x is equal to 4. So this is how I worked it out. Yeah. Yeah, complex numbers are same as imaginary. Yes, okay. So now if you guys are able to work out, at least understand the question, then I'll be able to work it out. So alpha squared plus beta squared. Alpha squared plus beta squared, I can say is equal to alpha plus beta the whole squared minus 2 times alpha beta. Yeah. So now I'll do the first one in red here. So it is alpha plus beta squared minus 2 alpha beta. So now what is the sum of roots here going to be equal to? Sum of roots will become minus b by a the whole squared. Yeah, minus 2 times product of roots will become c by a. So this is what will be the answer for the first one. So that is equal to b squared by a squared minus 2 times c by a. So this is equal to alpha squared plus beta squared. So now you guys know it. Now you try to work it out. So here if I take LCM, I'll get alpha plus beta and alpha beta. Now already from here you can get the product of roots and you can get the sum of roots. If you look at this, this is equal to alpha squared plus beta squared by alpha squared beta squared. So this also now you know. So try to work it out now. Yes, each one of you, please try to work out all 5 of them. I've given you adequate hints. So here alpha minus beta is equal to root over of alpha plus beta the whole squared minus 4 times alpha beta. So now you can find out alpha plus beta the whole squared and then get it. Alpha squared minus beta squared is equal to alpha plus beta into alpha minus beta. So there are many ways. There are you know alpha plus beta and you know how to find out alpha minus beta. So quickly work out all these questions. Yeah, yeah, please work out, please work out. Please sit down and then take out your notebook and then start working on them. Good, you all are doing good. But I just want to make sure that everybody is doing it. Complex roots and imaginary roots are the same. So we will learn that when we go to 11th standard, we will learn more about that. So third one, if I have to do, so this is equal to alpha plus beta the whole square minus 2 times alpha beta divided by alpha beta the whole square. So from the first question, you can get the value for, or directly you can look at this. From the first question, you can get the value of alpha square plus beta square, and then from there you can work on. Yes, fourth question. You are having doubts in the fourth question. Alpha minus beta. Alpha minus beta. Okay, I'll do it. I'll do the fourth question for you. See, I'm saying ax square plus bx plus c is equal to 0. Alpha and beta are the roots. I'm asking you for alpha minus beta. Okay. Now, alpha minus beta, can you say is equal to alpha minus beta the whole square? So that, do you understand, is equal to root over of alpha square plus beta square minus 2 alpha beta? Yeah. So which I can say is equal to root over of alpha plus alpha square plus beta square plus 2 alpha beta minus 4 alpha beta. So that is equal to root over of alpha plus beta the whole square minus 4 alpha beta. So now I know alpha plus beta the whole square. What is that equal to? B by A. So this is equal to root over of B by A the whole square minus 4 times C by A. So what is this? This is equal to alpha minus beta. Now alpha squared minus beta squared is nothing but the sum of roots. Yeah, so if you guys have got it, how the root will come in 4 7? Huh? I explained to you alpha minus beta the whole squared is equal to alpha squared plus beta squared minus 2 alpha beta. Now alpha plus beta the whole squared is equal to alpha squared plus beta squared plus 2 alpha beta. So I am going to write this in this form. So I'll add and subtract. So I'll get alpha square plus beta squared minus 2 alpha beta plus 2 alpha beta minus 2 alpha beta. So now this and this will give me alpha plus beta the whole squared. Now this will give me minus 4 alpha beta. So that is it. That is how you will work. Yeah. Okay. So that's how it came. Okay, okay, fine, good. So finish working. Once you finish working, I will wait for another 3-4 minutes and then I will work. Don't have to send me the answers, you just work it out, no problem. Where is my question? Yeah. So please work it out. Okay, so if this is working out, I am fine. So eighth slide I will show. Okay. Okay, so if you all have done this, the last one is easy. Once you get alpha minus beta, you know alpha plus beta, you know alpha minus beta. So you just have to substitute. So from here I can say alpha minus beta is equal to root over of alpha plus beta the whole square. So b square by a square minus 4 times alpha beta. Alpha beta is c by a. So minus 4 times c by a. So this is equal to alpha minus beta. So for the last one, I asked you what is alpha squared minus beta squared. So you can say that is equal to, so we know alpha plus beta, we know alpha minus beta. So we can move on from there. Okay. So if you understand this, then let's move on. So now, do you realize that if the roots of a quadratic equation, if the roots of a quadratic equation are reciprocal to each other, what does it mean? If the roots of a quadratic equation are reciprocal to each other, what does it mean? That if one root is alpha, the other root is 1 by alpha. So in this case, then what will be the product of roots? Product of roots will become 1. So if I have a equation x square plus bx plus 1, what can you say about the nature of roots? They are reciprocal to each other. What can you say about this ax square plus bx plus a? What are the, now I can take a common. Now if I take a common, I'll get x square plus b by a x plus 1. That means now the roots will be reciprocal to each other. Yeah, so can you make some notes here? So like this, if we keep analyzing, we can do so much more. We will do few more, we will do, but please make notes. Yeah. Okay. Now I'm saying, suppose ax square plus bx plus c is equal to 0 is a quadratic equation where the roots are reciprocal to each other. Reciprocal to each other. What does this word reciprocal mean? Reciprocal means if one is alpha, the other is 1 by alpha. If one is alpha, the other is 1 by alpha. So, what is the product of roots? Product of roots is what? C by A. Now, C by A should be equal to alpha into 1 by alpha. How much is that? 1. Then what does it mean? That C is equal to A. That means the equation is of the form ax square plus bx plus a is equal to 0. So, if an equation is of this form, then the roots will be reciprocal to each other. Yeah. Then now suppose ax square plus bx plus c is equal to 0 as a quadratic equation. Let alpha and beta be the roots. Okay. Now if both the roots are positive, suppose if both the roots are positive, so what is the condition that both the roots are positive? So can I say that one alpha is equal to minus b plus plus root over of b squared minus 4ac by 2 times a? Then I can say beta is equal to minus b minus root over of b squared minus 4ac by 2 times a. Yeah. Now we are trying to look at the condition when both are positive. So when is it that both will be positive? So so can we think a little and then say minus b? Sorry, I don't minus alpha. Both are positive. If both are positive, then see, this is a positive number and this has to be a negative number. Yeah. So first thing is that b should be negative. Yeah, b should be negative, so that when you do minus b, it becomes positive. Then the second thing is that minus b should be greater than root over of b squared minus 4ac. Yeah. Now if I, yeah, minus b should be greater than b squared minus 4ac. Yeah. So now if I square this, what will happen is that there will be a change in the sign here. So it will become b square is less than, I'm sorry, no change in the sign. B squared will be greater than b squared minus 4ac. So yeah, so now I can cancel these two and I can remove the negative sign by changing this. So I'll get AC is greater than 0. That product of this number and this number should be greater than 0 and B should be negative. So that is the condition that both alpha and beta are positive. I'll explain this once again. See, I am asking you a question. What is the condition? What is the condition for a quadratic equation to have both roots positive? What is the condition for a quadratic equation to have both roots positive? Okay, so now I'm trying to work this out. How? Suppose ax square plus bx plus c is equal to 0 is the quadratic equation. So 1 root alpha is equal to minus b plus root over of b squared minus 4ac by 2a. This is positive. And the other root beta is equal to minus b minus root over of b squared minus 4ac by 2a. This is also positive. So now if both the numbers are positive, do you realize that minus b should be positive? Should be positive. And also minus b should be greater than root over of b squared minus 4ac, so that when you subtract 1 it will still be greater than 0. So now I'm going to square this. If I square this, I'll get b square greater than b squared minus 4ac. So I'll take 4ac to the other side. So it will become 4ac is greater than b squared minus b squared. That means ac is greater than 0. So there are two conditions it has to satisfy. One, that minus b should be positive. So if minus b should be positive, then what can you say about b? B should be negative. Not only should b be negative, also ac is greater than 0. That means product of a and c should be greater than 0. Either both are positive or both are negative. Do we get it? Okay. Yeah. The denominator also must be positive. We are right. How did we get the equations for alpha and beta? That's what we did in the last class. That's what we did in the last class. Here there is a by 2a, right? So we have to talk about by 2a also. By 2a also. So we can't just cancel it and ignore it. So I mean, not here actually, it is here that works out. Here that it works out that minus b by 2a should be positive. Yeah, minus b by 2a should be positive. So if minus b by 2a should be positive, b by 2a should be negative. Should be negative. So as long as b by 2a is negative and ac is greater than 0, both the roots will be positive. Okay, so if you understand this, very good. If you don't understand this, don't worry about it. These are quite complicated cases. So if you keep working on it, slowly you will get it. Okay. Now I want to discuss one more. I have to discuss only two more concepts. One next concept I will discuss now. Suppose ax square plus bx plus c is equal to 0 is a quadratic equation, and let alpha and beta be its roots. Okay, let alpha and beta be its roots. Now I want another equation. Another equation where 1 by alpha and 1 by beta are the roots. Okay, so I want another equation where 1 by alpha and 1 by beta are the roots. So we can construct it. We'll say x square minus sum of roots 1 by alpha plus 1 by beta x plus product of roots 1 by alpha into 1 by beta. This is equal to 0. So I'll have x square minus alpha plus beta by alpha beta x plus 1 by alpha beta. Yeah, now I can substitute from here. Here alpha plus beta is equal to how much? Minus b by a. Alpha beta is equal to how much? C by a. So if I substitute, I'll get x square minus alpha plus beta minus b by a divided by alpha beta c by a x plus a by c. 1 by alpha beta will become a by c. Here the a's will get cancelled. Yeah, so it looks like x square plus bx by c plus a by c is equal to 0. Now I'll rearrange it. So it becomes cx square plus bx plus a is equal to 0. So if ax plus b square plus c is an equation where alpha beta are the roots, another equation where 1 by alpha and 1 by beta are the roots can simply be got by this. Yeah, are you able to understand this? Please make notes, please be working. Only when you work you will understand, otherwise it won't. Yeah. I already did the 5 questions that I gave. You send me your work, I'll correct it and I will give you. You all have my number. So please send me your work, I'll correct it. First finish this one. This is my number. Okay, so please send me work. There is no spoon feeding, we have to do the work. Yeah, okay, so please reach this. So cx square plus bx plus a is equal to 0. Now I'll explain the same thing with slightly different logics. See, ax square plus bx plus c is equal to 0 is a quadratic equation whose roots are alpha and beta. That means what? If I put x is equal to alpha, I'll get 0. If I put x is equal to beta, I'll get 0. Now I want to put some y such that y is equal to 1 by alpha. So if y is equal to 1 by alpha, alpha is equal to what? 1 by y. Yeah, but alpha is equal to x. So from there I can say y is equal to 1 by x. That means instead of x, if I put 1 upon x, I'll get an equation where y will become equal to 1 by alpha. So I'll have a into 1 by x the whole squared plus b by x plus c is equal to 0. On rearrangement, I'll get a plus bx plus cx square. Yeah, so you will get a plus bx plus cx square is equal to 0. Okay. Yeah, I'll explain once more. Yes. First equation, it is x square. Okay, let me go here. Okay. Okay, so let me come back to this. See, if you have an equation ax square plus bx plus c is equal to 0, then let alpha and beta be its roots. If alpha and beta are its roots, then what do you mean? You mean x is equal to alpha and you mean x is equal to beta will make it 0. That means x minus alpha is equal to 0. That means x minus beta is equal to 0. That means the quadratic equation is written as a into x minus alpha 0 into this, which is equal to 0. So now if I expand this, what am I getting? A x square minus alpha x minus beta x plus alpha beta is equal to 0. That means what am I getting? A x square minus alpha plus beta x plus alpha beta is equal to 0. Now what are we saying? We are saying that minus alpha plus beta is equal to sum of roots. It can't be plus because this is plus here, right? So if I take a common, it is x square plus b by a x plus c. So this is equal to this much. Now because this is equal to this much, that minus is coming. Now here that minus is not there, so I don't have to bother about it. So c by a. So negative of alpha plus beta is equal to b by a. So sum of roots is equal to minus b by a. So this negative sign is coming from there. Product of roots is equal to c by a. There is no negative sign. This is also plus. This is also plus. So when I compare, I am perfect. So this is one thing that you all will have to understand. Alpha plus beta, sum of roots is equal to minus b by a, and product of roots is equal to c by a. Okay. So that is where that negative sign is coming. Okay. Yeah. Yeah, I'll give many more examples. Don't worry about it. As long as you are able to understand, I'm okay with it. Yes, Pranav, you wanted to say something, you can quickly say, not too much time. If you understand it, let's fine. Let's move on. Okay, so I come back. So see, I have ax square plus bx plus c is equal to 0. Okay, now alpha and beta are the roots of this equation. I want another equation whose roots are 1 by alpha and 1 by beta. That means I want x to be equal to 1 by alpha and x to be equal to 1 by beta. So what is alpha equal to? 1 upon x. But now if I substitute alpha here, I'll get 0. So if I put a into 1 upon x the whole square plus b upon x plus c is equal to 0. So I'll get a by x square plus b by x plus c is equal to 0. Now if I take LCM, I'll get a plus bx plus cx square is equal to 0. So an equation whose roots are reciprocal of this will be this much. Okay, I'll cover this again in the next class. Okay, so please, you don't have to worry about it. So don't worry, I will cover this again in the next class. Next class will be our last class on this. We will finish off everything by the next class. Okay, so this. So now you want more examples. So I'll give you one more example. Suppose ax square plus bx plus c is equal to 0, which has its roots as alpha beta. I want another equation whose roots are alpha plus 2 and beta plus 2. Yeah, I want another equation whose roots are alpha plus 2 and beta plus 2. So how do I go ahead with it? So what are we saying? That x is equal to alpha. So if x is equal to alpha, but we want another equation where we want the x to be equal to alpha plus 2. That means alpha is equal to x minus 2. That means in this case, if I put alpha, I'll get 0. That means if I put x minus 2 also, I'll get 0. So if I have a x minus 2 the whole square plus b x minus 2 plus c is equal to 0. If you expand this, you will get an equation whose roots are alpha plus 2 and beta plus 2. Yeah, so let us expand this. So it will become ax square plus 4 minus 4x plus bx minus 2b plus c is equal to 0. So it looks like ax square plus 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 4a minus 4ax plus bx minus 2b plus c is equal to 0. So now I can rearrange ax square plus b minus 4ax plus 4a minus 2b plus c is equal to 0. So this is the quadratic equation whose roots will be alpha plus 2 and beta plus 2. This is the quadratic equation whose roots will be alpha plus 2 and beta plus 2. Sir, why can't you put alpha plus 2, beta plus 2 in place of x? You can't put alpha plus 2, beta plus 2 because, see, what do you mean by the roots are alpha and beta? That if you put x is equal to alpha, it becomes 0. Correct? Do you understand that? Now, if you put x is equal to alpha, it is 0 means alpha plus 2, it won't be 0. But we want another equation where we want to put x is equal to alpha plus 2. So now I am trying to tell you how are these two related. So that x minus 2 will become equal to alpha. So we can put only x minus 2. We can't put x plus 2. Rajiv, did you get it? Okay, don't worry, you think about this. We will work on this again in the next class. We will work on this again and we will keep doing it till we get it. I'll do 5-6 more examples and then we will be able to work it out. Yeah. Okay. Fine. I'll just show you the slides. You all can try to work on them. We did quite a bit. So second slide, third slide. So this minus b is equal to alpha plus beta. Now from there it is coming. Please work out. Please write all these things. Don't just say that teacher has written that way. It doesn't work. Sixth one. Seventh slide. Eighth slide. Tenth one. 11th. 12th. Thirteen. 14. 15. 16. 17. Last one. Okay, we'll continue from here. Next class we will complete this chapter. Please read. Then can we find product and substitute? Nitya, what are you asking? Then sir, can we find the sum of alpha plus 2, beta plus 2 and substitute? Okay, Nitya, what you are asking is, you are asking this. You can do that. What you can do is, yeah, you can do. So now sum of roots will be alpha plus 2 plus beta plus 2. So that will become alpha plus beta plus 4. Now alpha plus beta is minus b by a. So it will become minus b by a plus 4. No problem. Then alpha plus 2 into beta plus 2 is the sum of roots. So this is equal to alpha beta plus 2 times alpha plus beta plus 4. So what is alpha beta equal to? C by a, 2 times minus b by a plus 4. Yeah, yeah. Now you can substitute this and this. So it is x square minus minus b by a plus 4x plus this much, c by a minus 2b by a plus 4. Yes, you can substitute. Now you rearrange this. When you rearrange this, you'll get exactly the same answer as what we got. Yeah, so you can do this. Perfect. Okay, so goodbye. Then we can continue from here. Next time we'll finish it off. Bye.